Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you here today, as it is every day here in my virtual classroom. Step on the side as we jump into section 4.2 in the Big Ideas Math Integrated Math 1 textbook. We are writing equations in a new form called point-slope form. Now again, we've heard standard form before, ax plus by equals c, and slope-intercept form, our favorite, y equals mx plus b. There's a new third form for which we never graphed out of, but we are going to write equations out of, and we'll see if we ever graph out of them in the future. This chapter is on writing equations. There's a reason we're going to do this one. If you notice the last one in slope-intercept form, the last section, we were writing equations in it, but every problem actually had the y-intercept featured. It made sense to use slope-intercept form. But what if you don't have the y-intercept? What if we have 2 points, or other information, but we don't have the y-intercept as one of those points? There is still a way in writing them in slope-intercept form. There are 2 different methods to get there. One of them is to start out in the form called point-slope form, and we're going to show you that one here today. It's great exposure to have and to know what to do with. I'm telling you, in the future, calculus still uses it, pre-calc, all those ones in the future. Maybe there's a time off in between then. It's a little more confusing looking. If you did section 3.6 with us on transformations, you saw that x minus h thing. Some of the stuff might make a little bit of sense here as far as things being reversed, but we're going to get into it right now with the lecture portion. If you want to jump down to the description section down below, you can get this PDF and follow along with the lecture portion. Also find the problem set thereafter. We didn't have to do any graphs last time. I doubt we have to do any graphs this time. Let's go ahead and take a look at what we are going to be featuring here today. We're going to write an equation of a line given its slope and a point on the line. So I'm sure we're going to get very quick, easy problems like we had for the slope-intercept form ones. Given slope and y-intercept, write the equation. Boom. Point-slope form, if you have a point and a slope, boom, it's going to be that simple as substitution. Write an equation given 2 points on the line. So we were given 2 points before, but again, one was always the y-intercept. What if you have one that's not, or both are not the y-intercept? Now what do? Point-slope form's the answer. We still have to find slope, but we'll do that. And use linear equations to solve real-life problems. Okay, more of the same, only we'll see what kinds of word problems they're going to do with us. Okay. In point-slope form, let's see how they begin. They say given a point on a line and the slope of a line, you can write an equation of that line. Yes. Consider the line that passes through 2, 3, and a slope of 1/2. Let xy be another point on the line where, x doesn't equal 2. They don't want x to equal 2 because in this case we have a value where x equals 2. So let's find some other point that's on there. It could be 3, it could be, I guess not 0, because they don't want y-intercept, but -1, whatever. You can write an equation relating x and y using the slope formula. Oh, okay, so cool. So they have an interesting way of showing you how this point-slope form is going to work. So they're substituting this as some x1, y1. Our x2, y2 is unknown, so we call them as x and y. Or they can represent any other point on there. It's not like we're solving for it. They just represent some other point on there. So our slope is y2 minus y1 over x2 minus x1. That's our formula. If we substitute 2 and 3 for our x1 and our y1 in this formula, then we have the equation looks like this. Kind of strange looking proportion. But if you multiply both sides by x minus 2, remember this would represent an entire quantity, and x minus 2 divided by x minus 2 is 1. Now y minus 3 is here, and 1/2 is multiplying by x minus 2 over here. And let's rewrite this so the y term, it's not by itself, but it's on the left side of the equation. So now this will say y minus 3 equals 1/2 times x minus 2. What you're looking at is the point-slope form of this equation. Now, it looks a little weird. The process for which we got there was very weird. We're not going to come from the process. We're going to come from the formula, which I just said looks a little weird. So this is the appearance of the equations we're going to be writing in this section, guys. If they're asking us to write answers, this is what they're going to look like. I need to keep stressing that. We will not be distributing, unless we want to get slope-intercept form. Our goal is not to distribute this or anything because this is a graphable form, something we can work off of. Point-slope form. A linear equation written in the form y minus y1 equals m times the quantity x minus x1 is in point-slope form. The line passes through the point x1, y1, and the slope of the line is m. So visually, if we don't have a point that's on the y-axis, then we probably shouldn't use slope-intercept form off the bat. So we have another form that represents starting from some other point and applying your slope from. Remember when I don't know if you saw the questions, but there were some where it's like, all right, yeah, we start from this, we do our slope up this over that, we draw our graph, we did this last chapter. But what if your y-intercept was, 20 and you couldn't fit it on there? Find another point, pick that, and just do your rise and run from there, man, and plot your points and make your graph. Well, that's kind of like what this is. You don't have to start on the y-axis, you just have to start on a point. So if your point's not on the y-axis, here it is. Now, we're not graphing them. we're writing equations with their graphs or with information. So I wish we did graphs. I wish we did graphs. Maybe we'll do them in a future set. Maybe they'll ask some questions for us to graph here. I don't really know. But we are going to be writing equations. And once again, here is the formula. Now, the tricky part about it is, number one, it looks a little weird. We have some subscripts, the y1 and x1, and that's where we're actually substituting the points on the graph. In the equation, I should say. They're going in there. Number two, parentheses, and all right, you're normally used to distributing them and such, but this time it's actually a part of the quantity. The slope is multiplying by that. And number three, this is the part that if you came off of section 3.6 on transformations, you might understand it slightly, but otherwise you won't. These formulas have subtraction. These formulas have subtraction, and because the formula has subtraction, whenever a number is written inside of there, it will appear opposite of what it's supposed to be. Before we do the examples down below, do you remember the example up above? This says y minus 3 and x minus 2. Do you remember the point that was on the graph? Was it negative 2 comma negative 3? No, it was 2 comma 3. So the numbers that you see or that we write in the formula will be opposite of the values that are provided. That means if these are positives, we'll write a minus inside of there. If these are negatives, we are going to write pluses because that's minus and negative. That should look familiar to the whole f of x minus h thing we were doing. H, when it says x minus 4, we translate 4 units to the right, not to the left. When it says x plus 7, we translate 7 units to the left, not to the right. So it was opposite of what's there. This is the same kind of effect, and really for the same reasons. We're not really getting into that, but it's opposite of what you see. I want to stress that. Okay, weird looking formula. We're going to have to keep in mind what it is. They'll show it in the lecture portion, obviously, through the examples. All right, first one. Write an equation in point slope form of the line that passes through the point negative 8, 3 and has a slope of 1/4. We're literally given our information that we need here. We have our x1, y1 value and our m value that we need to plug into the formula. Here's our equation, our formula. So let's plug them in. Y minus y1. y1 is 3, so it'll say y minus 3 equals m 1/4 times x minus x1. Now here's where we subtract negative 8. That becomes x plus 8. So this is the formula, y minus 3 equals 1/4 times the quantity x plus 8. Again, I know it looks weird. You're going to say, Mr. Robinson, that looks so weird. Isn't there an easier way to do it? No, this is literally the easiest way to do it. This form is actually presenting every part of this. And remember where it came from, the slope formula. And the slope formula comes from changes in y over change in x. This is an interpretation of it. That's not to say, and I don't know if they're going to do it, that's not to say there's not a slope-intercept form version of this. But because we don't have the y-intercept, we have to do some work to get there. So regardless of what you do, it still takes some work to get there. And how do you get in slope-intercept form? You get y by itself and you distribute the 1/4. If you want to write it, it's y equals 1/4 x plus 5, but you're going to have to do some work to get there. But this is the point slope form version. If I go to Desmos, a graphing calculator, and type this in, I'd get the line that goes through this point and gets that slope. And that's what we want. So that's one example, using direct information, boom, straight substitution. But what if we're given 2 points? Now keep in mind, in the last section, one of the points was always a y-intercept. In these examples, we will not have, let's see, where are they? We will not have the y-intercept as one of those points. Now, I know what you're thinking in these cases here. If you draw enough on the graph, you can find the y-intercept, and I get it. Guys, this is not the section for it. This isn't the section for it. This section for it is to work off of point slope form, have a different version in play when we don't have those. When the y-intercept is a bizarro fraction that you are not going to want to have or get a common denominator for, this is the time. And I say this in a very humanly way to you, right? I'm not a teacher right now. I'm saying this in a very personable way and just saying, follow it for the reason of when you need it. Follow it for the reason of when you need it. I say that because people can become standoffish on it. It looks weird, therefore I don't want to use it. I don't want to have to memorize it. Things like that. Well, this is what the practice is for. Accept it, warm up to it. It does have its benefits. It really, really does. Listen, if calculus uses it, then you have to think that eventually we like it. All right, anyway, sorry about the tangent. Let's go back to this one. Writing equations of lines given 2 points. Okay, if you're given 2 points, think about your formula. Your formula needs 1 point and it needs a slope. Well, we don't have slope yet, but we do have 2 points and we can find the slope off of it. Find the slope of the line. y2 minus y1 over x2 minus x1, right? So in this setup, we can find the slope. Now, with the graphs, guys, I'm going to do the slope using the rise over run stuff. Down 4, right 2. Down 4, right 2 has a slope of negative 2. I'll do that. The next thing is not y-intercept. The next thing is choosing a point. Here's the cool part, and I don't know if they say it. Use the slope and one of the points. You can use one or the other. You don't need to use both. You can make a choice, the easier one, the harder one, flip a coin, it doesn't matter. You can choose one or the other. They both represent the same graph. So they chose the point 1, 2, this one right here, as their x1, y1 to substitute in here. Their slope's negative 2. So look, this is the same setup as the previous example now. Now you have your slope, you have a point, and we plug them in. Y minus y1 equals m times x minus x1. Now, what they did after that was exactly what I was talking about. If you want to, oh, did they say? Oh, perfect. They said write it in slope-intercept form. So guys, you want to write in slope-intercept form? You can, but start in point-slope form. It can get you there. So if we substitute, I should really read these lectures beforehand. If we start here, we can then distribute the negative 2 into these two terms. And then we can add this 2 to both sides here. And of course, you combine it with there, you get y equals negative 2x plus 4. So we get there. We get there. Now, how can we confirm this is a correct answer? Using the graph, again, remember if we kind of just use this to go up a little bit more, let's go another up 2 over 1. Yeah, that looks like that'll hit a y-intercept of 4. Okay, I get it. We can also use the other point. So this box is showing that the other point was 3, negative 2. Look, they're going to substitute 3 for x1 and negative 2 for y1. It becomes a y plus 2. They distribute negative 2 into here, and then they subtract 2 from both sides. You still get y equals negative 2x plus 4. No matter which set of points you use, no matter which point you use, as long as it is a solution to your line, to your equation, it will get you the same equation in slope-intercept form. These might look different in this form right here and right here, but they both represent, oh, I guess it's not distributed yet, but they both represent the same line. Either or, either or. Example 3, writing a linear function. No different from what we did last time, so I'm going to go very quickly on this one here. This is an xy, x1, y1, x2, y2, that kind of thing like that. We can use these points to first get a slope, and then pick either of the 2 points, this xy or this xy, to plug in. They're saying slope-intercept form again, so listen, they're getting back in your slope-intercept form, okay? Be accepting of that. There is another method to get into slope-intercept form with this, and I thought they were going to talk about it in the last section, but because they didn't, I'm not going to talk about it right now. But you can use either point to do that. Once you find your slope, I would have preferred to write my slope as a fraction of 3/2, but that's okay. Anyway, so with that one, they distribute and they subtract, or they add the 4 over, and they get y equals 1.5x minus 8. Or f of x equals, pardon me, function notation. Real life problem. First of all, we're number 1. Okay, a student council is ordering customized foam bands to promote school spirit. We have a table that shows the cost of ordering different numbers of foam hands. Order 4, 6, 8, 10, or 12 foam hands, and this is how much they'll cost. Can the situation be modeled by a linear equation? Explain. If possible, write a linear model that represents cost as a function. Well, it would be weird if if the lecture example couldn't be written as one, and they just said move on and we didn't do the problem. So I guess it can. But how do you know? Probably by a constant rate of change in x, we're going to see a constant rate of change in y. As these add 2 each time, these are adding 12 each time. And as they add 12, in fact, that's how I should have done slope on my example from the previous section. If they're increasing by 12 each time here, and they're increasing by 2 each time here, then 12 over 2 is 6. So we have a slope of 6, and they're showing using a slope formula that you get a slope of 6 no matter what you do. So therefore, your slope is 6, and you can choose any of the points here. I like to go smallest, but you can choose any of the points here to represent something for your solution. x1, y1, sure. Which ones do they use? They chose, what did they choose? Oh, yeah, they chose them, 4 and 34. So the smallest numbers, why not? Now, they get it in slope-intercept form, y equals mx plus b. And was that it? They just said write the equation? Yeah, write a model. I thought they were going to say then use it to predict how much after 20 foam finger things. And that's it. All right, there's the lecture portion. Let's go to the vocabulary and core concept check, and then we'll get the problem set. Without simplifying, number 1, identify the slope of the line given by the equation y minus 5 equals negative 2 times x plus 5. Then identify one point on the line. Okay, so with this one here, remember the point slope formula is y minus y1 equals m times x minus x1. That's your formula. That means your slope is m. That's this negative 2 that's written right there. your point that this is crossing through, and I'm going to use the letter P to represent the point on this. Your x1, y1 is going to be x minus x1 is x plus 5. Well, this says a plus, that says a minus. That must mean you're subtracting negative 5. This says y minus 5, therefore this y is a positive 5, the y1. This is the point that we're crossing through right there. Number 2, in writing, explain how you can use the slope formula to write an equation of the line that passes through 3, negative 2, and has a slope of 4. I use the slope formula. Okay, well, I'm not going to go based off of the slope formula, but what you can do is plug these in for the x1, y1, and then you'll have your x2, y2 just be some random xy. I'm not going to explain it. I'm going to actually do it. So your slope 4 equals y2, which is our unknown, minus y1, minus negative 2 is plus 2, over x2, which is unknown, minus x1, which is 3. If you multiply both sides by x minus 3, then you have no fraction, and you really have the appearance of point slope form. If you notice here, now y plus 2 is on its own side of the equation. I'll write it on the left side. And let's swap these around. I'll have 4 written first and then x minus 3 second. And here's your point slope formula. Why are they telling you this if we're not going to do it that way? So you have a way to go back to in case you do forget the formula. Point slope form is based off the slope formula. So if you know the slope formula, in a way, in the recess of your mind, you have a way to get point slope form. All right, guys, we're going to get into the problem set. We have 40 questions to do. Well, 38 now that we've done the first 2 of them. I just want to state again as I've gone through the lecture, because I start to realize things for myself, we are revisiting slope-intercept form again. And this is the way that they want to teach how to write slope-intercept form. Start from point slope form. I'm fine with it. I like it. But we're also going to write out of point slope form for each individual problem. Without further ado, guys, I'm going to go ahead and get started. We have questions number 3 through 10, where it says write an equation in point slope form of the line that passes through the given point and has the given slope. So these are as direct as you can get. Once again, your point slope formula looks like y minus y1 equals m times the quantity x minus x1. So on number 3, we have a point that we're going through that's 2, 1, and your slope is 2. I'm used to writing p for point. I know they didn't do that. So this is y minus, this is our y1 right here, and our x1, and there's our slope. So y minus y1 equals m times x minus x1. Straight up, there's your formula. It's graphable. We didn't get to graph out a point slope form. That's the point where I think that you might be a little bit more standoffish with it. That you might go like, what does this formula mean to me? I'm writing something, but I don't know what it means. That's because we never got to graph out of it. So hopefully we get to graph out of it someday. Today's not that day, apparently. We have this point and this right here. Again, I'm not going to say it's as easy as y equals mx plus b, but it's the same idea as y equals mx plus b. You have the information for this formula. We just got to substitute them. Y minus y1 this time is y minus 5, and m is negative 1 times x minus x1 like this. I'll tell you what, if they give you point slope formula as an answer or as a problem, they might not show this as a negative 1. Keep in mind, they might just show it as a negative symbol like that. There are a lot of implied ones when it comes to multiplication, exponentiation, things like that. So if you see a negative there, please understand your slope is negative 1. That's before distribution. Number 5, we see our y1 this time is a negative number. I'm going to be very literal on the first time that I write this one, and some days I'll clean it up a little bit more quickly. So in this case here, for our y minus y1, it's y minus negative 4, and negative 6 is our slope, and we have x minus x1 here. We are not going to leave it like this, right? We're going to subtract a negative, turn it into plus. Y plus 4 equals negative 6 times the quantity x minus 7. They do want point slope form as our equation set, not slope-intercept form. We will get things into slope-intercept form. Actually, it looks like starting at number 11. But just start with this form. Number 6, both of these are negative, which again, it's that thing with the formula. These will become opposite of what they were. So y minus negative 2 will turn into y plus 2. 5 is your slope, and inside here we get x minus negative 8, which will become x plus 8. So as you get more used to this form, and by the way, this is probably your first introduction, well, 3.6 was your first introduction of this. This is probably the first time you're writing equations in this form and leaving it like that. When we do some things in IM2, IM3 of these kinds of forms as well, you're going to get used to seeing these whole opposite of kind of thing. You flip this sign, that kind of stuff. So this might be the first exposure to it, but it'll show up again. Number 7. 9 comma 0 is the point this goes through. What happens when there's a 0 for the y value? I guess that's your x-intercept. Does that matter much? No. Y minus 0 equals m times x minus 9. In a way, this is almost looking to us like, because y minus 0 is y, right? So that's y equals negative 3 times quantity x minus 9. I mean, guess what? If I distributed negative 3, I'd get into slope-intercept form. We are that close. But yeah, totally simplify it right like that, right? Don't leave it as y minus 0. If you're given y equals, and they say it's point-slope form, whatever you need to know, that's y minus 0, though. Number 8, our point is 0, comma 2, and our slope is 4. You guys are probably chomping at the bit saying, can I just write slope-intercept form right there? I have the y-intercept. Listen, if this is a review, if this is the Chapter 4 test and cumulative assessment, and they said write an equation using any method of your choice, any form of your choice, I'm using slope-intercept form. But they said use point-slope form. So we're going to go and do that. Y minus 2 equals m times x minus 0. But of course, what is x minus 0? It's also just x. And what's 4 times x? Well, it's 4x. So this is the appearance there in simplified form. It looks weird. And if I add 2 over, it's 4x plus 2. I get it. I get it. And I hope you do too. But that's point slope form. Number 9, negative 6, 6. This time, let's do it straight into the answer from here. Oops, that's our point. M is 3 halves. It's okay if it's a slope. If it's a fraction, I'm going to write y minus 6 equals m times x plus 6, right? We're subtracting the negative on that guy, so there's the form. And number 10, this time the 12 is negative for y sub 1. So that point is 5, negative 12. We have a slope of negative 2/5. This time, instead of writing y minus 12, it's y plus 12. And this equals negative 2/5 times x minus 5. So those are our sets to begin with in point slope form, and we are going to begin in point slope form. Listen, this section is called point slope form, but we're going to begin in point slope form even for the next section when we write things eventually in slope-intercept form. Okay, numbers 11 through 14 say, write an equation in slope-intercept form, the line shown. I need to stress this really importantly because it's clear as day that they show you. Look, I already talked about this. I already got on my soapbox about this. I think you and I can all agree that we can see where the y-intercepts are right here, right here, right here, and right here. The goal, in my belief, the goal is for them to let you see what it is, not so you can write the answer immediately. It's so you can use point slope form to see that you can get in slope intercept form and agree that the answer that you got is the correct one. And that's going to be our plan. Remember the section that we're in. It's in point slope form right now. So we're going to write it in point slope form. I'm even, for the first problem at least, going to do it twice. I'm going to use it for this point as an x1, y1 and this point as an x1, y1 and show that I still get y equals whatever x minus 5, because that looks to be the y-intercept of this problem, right? Negative 5. There will be some questions where you don't have the graph, like these ones down below. There will be some questions where the y-intercept's a fraction or where it's out of window range and you can't use what you want to do. So let's practice this. Let's get it right. So we have 2 points here. This time I'm going to write the actual points. I got 1, negative 3 and 3, 1. Neither of these are the y-intercept, right? We don't know the y-intercept. We don't know it. Haha. We got an x1, y1, and x2, y2. I want you to think about it that way. Now, our slope, we can count. I'm fine using the graph for that. Our rise and our run. We're rising 1, 2, 3, 4, and we're running 1, 2. Our slope is 4 over 2, which is 2. Now we are at the same stage as we were for any other problem in the biz we've had. If we choose this as our x1, y1 for our formula, then we can write an equation that says y minus y1, right, equals m times x minus x1. Here's a point slope formula. Okay? Or we can choose this as our x1, y1, and we could write it as y minus y1 equals m times x minus x1. Now, these are two different versions of point-slope form. What they want eventually is slope-intercept form. How do we get slope-intercept form? Simplify this side and get y by itself. No matter what we do, if we distribute 2 to both sides here or here, and then eventually move that other term over, if I subtract 3 from both sides here, I will get y equals 2x minus 5. Over here, this becomes 2x minus 6, excuse me, 2x minus, hold on, I wrote something wrong. This is not a 3, this is a 1, y minus 1. 2x minus 6, and when I add 1 to both sides here, I get y equals 2x minus 5. Okay, what's the point we're making? Several points. First of all, that's the answer. That's your slope-intercept form. Second of all, you can use either solution. They are solutions. They should both work for your equation. You can use either solution given that slope, and you can write a point-slope form that works for either one, because when we get it in slope-intercept form, it's the same thing. Now, the next thing I want to mention is confirming that this does look like indeed that is a y-intercept of -5. Would have been a lot faster to write that? Yes, but the point is, how can you get in slope-intercept form? You can start with point-slope form to get there. And we're going to continue doing that. Am I going to use both sets of points? No. I'm only going to use one set of points and the one that I prefer. Sometimes it's the two smaller numbers, the ones that are positive, one that has 0, things like that. Now, number 12 does have a point with 0, -4, 0, and 1, -5. So our goal, again, is twofold. First, find the slope, then write point-slope form out of it so we can choose a point, plug it in, and get slope-intercept form out of it. So we're going down 1, 2, 3, 4, 5. We're running across 1, 2, 3, 4, 5. Our slope is -5 over 5, which is -1. So we can now write a formula. I'm going to use this as my x1, y1. We're going to write a formula that says y minus y1, that's y minus 0, equals m is -1. -1 times x minus x1, that's x plus 4. So my slope-intercept form equals y equals -x minus 4 when I distribute this. Now that went a lot faster than other ones would, because this was a 0, this one was a negative, things like that. That one's significantly faster, but that should still be the formula. Does that align? I'm not going to double check with this second point, but does that align with our y-intercept we see here? Yes, that looks like a -4. Now, the slope should be the same regardless of which point we're choosing. It's still a slope of -1, and you can confirm that as well. Down 1 over 1, down 1 over 1. So that seems to be our slope-intercept form answer. Number 13. Number 13, we have the points -6, 4 and -2, 2. And let's find the slope first by doing our down how much over how much here. We're going down 2 and over 4. Down 2, 4 to the right. So -2 over 4, which is -1/2. I'm going to leave it as a fraction. Let's choose either set of points to solve this. This time I'll just choose these points over here, the -2, 2, okay? This gives us an equation of y equals, we're doing point slope form, y minus 2, that's our y1, equals m, -1/2 times x minus x1, x minus -2 is x plus 2. To get it in slope-intercept form, we have to distribute the -1/2. -1/2 times x is, yes, -1/2 x. -1/2 times 2 is -1. Half of 2, make it negative, right? Now I get to add 2 over, and voila, we have our slope-intercept form of y equals -1/2 x plus 1. Does this graph cross at a y-intercept of 1? If not, something went wrong. Here, it does, so I feel good about it. Number 14, last one of graphing form to confirm that what we're getting are the right values. We have two positive sets. I bet we could even get the slope without looking at this graph, just by looking at the numbers. Let me just write down the points. Okay, guys, tell me how much we're rising from 1 to 4. 3? Okay. How much are we running from 4 to 8? 4? Got it. We have a slope of 3/4. Let's choose a point. Always choose the smaller ones when you can. That's not necessarily true. Try and choose numbers that Both of these will work. I'm going to choose the smaller ones, 4 and 1. So y minus y1 equals m times x minus x1. All right, good start. Let's distribute 3/4 into these two. What's 3/4 of 4? 3/4 of the way to 4. It's 3, right? 4 divided by 4 is 1 times 3 is 1. Times 3 is 3. So 3/4 x minus 1. And we get to add 1 to both sides. And this becomes y equals just 3/4 x, because that cancels out as well. Y equals 3/4 x. That must mean our y-intercept is what? 0? Let's see if it's 0. No. What did I do wrong? 3. I'm sorry. So I did do something wrong. This is why we double check. I kept saying 3/4 of 4 is 1. I apologize. For some reason that was stuck in my head. We add 3 to both. We add 1 to both sides, and -3 plus 1. This is embarrassing. -3 plus 1 is -2. Hey, this is why we're double checking the graphs. Or you can do it with the other method. So -2. Do we have a y-intercept of -2? That's better. Yes, these are scaled by 2's right there. So there's the answer. Apologies. I was stuck in this 3/4 of 4 is 1. Stupidity kind of thing. Okay, we're going to go to exercises 15 through 20. No graph. So you don't get to use any version of something to say, hey, I know what the y-intercept is. No, you don't. No, you don't. And maybe sometimes you're like, yeah, but if I track this back, I can get it. I get it. I want to see if we get any that are fractions. I kind of hope not, but that would be more reason why you'd want to keep something in point slope form when you could. All right, first set we have as points are 7, 2 and 2, 12. If you think there's anything different we're doing here than we were doing above, you crazy. However, this time to find slope, unless you're really good at counting that rise over run stuff in your head, asking yourselves the right questions, we're going to use the slope formula. I can do y2 minus y1 over x2 minus x1. And if you were with me for the last section, I try and keep my x terms positive, because if my y terms are positive, then my whole thing's positive. But this is -10 over +5, which is -2. So I'm going to choose 2 points. I'm going to choose these ones right here. Let's do y minus 2 equals m times x minus x1 there, 7. And they just said write it in slope-intercept form. So I'm going to distribute -2 to both sides. And then I'm going to add 2 to both sides like this. Now, just to double check that I'm getting the correct answer here, let's just for this one problem also now try it with this set of points here as well. Remember, this is still our slope. So now I'm going to say y minus, I keep writing y equals. Y minus 12 equals m times x minus 2. Here's your slope. Let's distribute the -2 into this set. This is y minus 12 equals -2x plus 4. And now we add 12 to both sides, and 4 plus 12 is 16. Y equals -2x plus 16. So you can always double check with both sets and see that you get the same slope-intercept form. Further validation that you got it correct. Number 16. Here are 2 sets of points. For the sake of practice, let's just practice a mental rise and run here. Our run from 6 to 12 is 6, and I'm choosing the positive route, so we'll go from -2 to 1. What's that rise? -2 to 1, we're 2 away from 0, and then 1 away from 1, that's 3. Rising 3. 3 over 6 is 1/2. I'm going to choose these 2 numbers. I'm going to choose numbers, if I can keep them positive, I think that's better for me. So my formula is going to say y minus y1 equals m times x minus x1. If I have 2 positives, I almost always use them first. Or if I had zeros. That's a 12, by the way. What's half of 12? Let's not say 1, Mr. Robinson, please. This time fix yourself. 6. So -6 here. If I add 1 to both sides, we get the equation y equals 1/2 x minus 5. I have nothing to back that up other than if I plugged in those numbers. I'm going to choose not to, but y equals 1/2 x plus 5. Or minus 5, excuse me. Looks good. Number 17. This time when it comes to choice of point, it's really up in the air for me. They're both featuring a negative y value, so this time you have to bite the bullet when it comes to writing the form and get to where you got to go. Maybe it's best to go in your slope formula, but you got to be careful here as well. Like y2 minus y1. Oh, wait. Let's see. Let's do -1 minus -7. Over x2 minus x1, 6 minus 3. It's negative 1 plus 7 over 3, or 6 over 3, which is 2. So choose either or, right? Choose smaller numbers, big. I guess these are slightly smaller. So this time y minus y1 is y minus 1. No, plus 1 equals m times x minus x1, like so. Let's distribute that 2 and see what's going on before we subtract the 1 over. We get 2x minus 12. So subtracting the 1, we get a couple minus 13s. So y equals 2x minus 13. Y equals 2x minus 13. Number 18. We're just getting more negatives, ain't we? Number 18, we have negative 2, 5, and negative 4, negative 5. All right, our slope. Let's see. Which way shall we go? From negative 4 to negative 2 is positive, so let's do this minus that. 5 minus negative 5 over negative 2 minus negative 4. Ugh, weird. 5 plus 5 over negative 2 plus 4. 10 over 2, or 5. So there's our slope. Now, which one has less negatives? I mean, this isn't always a required thing. It's just that if you don't want the negatives to mess you up on what's pluses, what's minuses, maybe you want to deal with just more of these. So I can write y minus 5 equals 5 times x plus 2. Or maybe you like some of these turning positive after the fact. You just got to remember to do it. So y minus 5 equals 5x plus 10. And when I add 5 to both sides here, it becomes y equals 5x plus 15. So far so good when it goes to slope-intercept form. Remember, this is our way of going about it given that we don't have y-intercepts on either of our sets of points. So point-slope form is the way to get there, and you can use either set of points to get there. Number 19. Okay. Can you tell that our rise, that we don't have a rise here, our slope's going to be 0? Listen, seriously, hopefully you can tell that. And this will also do some things in our point slope form as well, right? If you think about what our whole equation is, I mean, they said right in slope-intercept form. We should be able to say the answer from here. But let's still use point slope form. This time, let's use these sets of points just to, both negatives. Y plus 9 equals m times x plus 3. Distribute 0. Who am I kidding, guys? We're multiplying 0 by a quantity. What does that become? It becomes 0, right? This is y plus 9 equals 0. Let's subtract 9 from both sides. This is overkill. Y equals negative 9. We should have known that from the jump, right? Y equals negative 9. Hey, y is never going to change. It's been negative 9 from the very beginning. But point slope form still confirms it, right? Even if I chose y plus 9 equals 0 times x minus 1, the x minus 1 still cancels. 0 still nullifies it. So there's that. Number 20. Number 20, we go from negative 519 to 513. I want to ask you this one out loud, see if we can come up with it. How far is it from negative 5 to 5? Don't tell me 0. How far is it from negative 5 to 5? It's 10, right? It's 10. So we have a run of 10 from this number to this number. So let's go down from 19 to 13. We're going down 6. We're going down. That's negative 3/5, okay? So I have a slope of negative 3/5. Let's go ahead and choose these two positive sets to get this out. Y minus y1 equals m times x minus x1. Distribute this negative into a couple of these guys here. We get y minus 13 equals negative 3/5 x. All right. 5, let's see, negative times negative is a positive. 5 divided by 5 is 1 times 3 is 3. So there we go. And let's add that 13 over. And we get y equals negative 3/5 x plus 16. So we're still getting slope-intercept form. It's still our baby. It's still super valuable. Clearly, they're still showing there's purpose to it. I think part of it also is that they're like, hey, we don't love this form for everything. There are times you're going to want that. There are times where they'll just ask for it. I think, like when I always say, hey, calculus uses it, calculus uses it. It's because calculus doesn't care about getting slope-intercept form. They just care about an equation that does certain things. I'm not going to get into calculus with you, but they're fine with, hey, that's the answer. We're done. Here for slope-intercept form, what's part of the point? Remember, we want to see that it matched with our graphs. We want to say that no matter whether you plug in this point or this point, you get the same answer. And they're giving you another connection to equations. We've done standard form to slope-intercept form. Now we get to do point slope form to slope-intercept form. Okay. All right, write a linear function f with the given values. More of the same. The difference here is they're written in function notation to begin with, and if you were with me in the previous section, I caught on to it after the fact. Let's write the final result in function notation as well, okay? Now, I think the ever popular thing for us to do, and I agree, is let's write out the ordered pairs here. This is 2, -2, and this is 1, 1. So now that we have that set, let's figure out its slope. Let's do the same thing as before. They're saying write a linear function f. This is a case where you do have to get it in slope-intercept form. You can't have your final answer say f of x plus 3 or whatever. We don't do that. We end up getting it by itself. F as a function of x is, and then boom. So this time getting it slope-intercept form is like a must, right? Just because what it has. Anyway, we run from 1 to 2. That's a run of 1. And so from 1 to -2 is a fall of 3. So with -3 as the slope, oh, I of course want to use these 1s here. This is going to say y minus 1 equals -3 times x minus 1. Now, I do start with a y here to begin with instead of function notation because I don't like using function notation until it's by itself. It's a personal thing for me, and I think you guys would agree. It looks weird. So -3x plus 3 through distribution, and we add 1 to both sides. This is y equals -3x plus 4. But our final answer, let's write f of x equals. Let me write it over here. F of x equals -3x plus 4. If y'all don't mind, what I'm going to do from this step to this step here is this is where I'll turn the y into an f of x. You'll go like, whoa, what the heck? Where did this come from? And I'll just turn it into that at the end. Okay. All right, let's go to this one. F of 5 equals 7. F of -2 equals 0. We have inputs of 5 and -2. Those are our x values for these respective y values of 7 and 0. That makes -2 an x-intercept, not that it matters. So 5, 7, and -2, 0. All right, let's see. Let's go some old-fashioned y2 minus y1 over x2 minus x1 scenario. That's 7 over, that's 7. Minus a negative is that. Our slope's 1. That's cool. So let's try -2, 0. Let's really clean this thing up. This is y minus y1, y minus 0, equals 1 times, 1 times x minus -2 is x plus 2. What's 1 times x plus 2? It's x plus 2. So that would be the answer, except I forgot function notation. F of x equals x plus 2. And that would be the final result. That looks a lot cleaner to use than this set. You'd still get the same answer. Number 23. How far have we gone? 43 minutes? Ooh. I spent some time being very, I don't know if the word is philosophical or whatever. I was really talking about accept the formula, use it. This is why it happens. That's what you get out of my videos versus something else, right? You get philosophy. You get the talk. All right. Let's do y2 minus y1 over x2 minus x1. That's -5 over 10 or -1/2. Doesn't look like it matters which one to choose here. Kind of your choice. I'll go ahead with this one. I'm going to get an equation that says y minus 2 equals -1/2 times x plus 4. -1/2 times 4 is -2. So y minus 2 equals -1/2 x plus, or minus 2, excuse me. Minus 2, and I'm going to add 2 to both sides. In this case, the 2's go away. It looks like our y-intercept is actually 0. Y equals -1/2 x plus 0, or y equals -1/2 x. I said I'd turn it into function notation. I keep forgetting to do that. -1/2 x. All right, y-intercept was 0 on that one. Number 24. I don't know if you notice what's going on here, and if you do, I think we can write our answer a lot more quickly. F of -10 equals 4. F of -2 equals 4. Okay, I am going to start in point slope form, which means we need the slope first. If you notice, the y values, I'm going to do this as fast as possible. If you notice, the y values of both of these are both 4. Given different inputs, the same output of 4. That means our slope is 0. And we can choose an x1, y1 like this one. y minus 4 equals m times, who am I kidding? 0 times anything is 0. So guys, this is the point slope form version of it, simplified. Point slope version. Slope intercept form, add 4 to both sides, and we should have known this. We get y equals 4, or in this case, f of x equals 4. So we should have been able to know to write this answer ultimately from the beginning, but because we're starting from point slope form, I wanted to get there. Did I go faster in some parts still? Yeah. Yeah. But that still gets us there. All right. How's this going? So far, so good. Do we know the formula yet? I think that's the main question. Do we know the formula and what we can do with it? Those are the two questions that we want to say until we get to word problems. Okay. We need our rise and run. Let's go from negative 13 to, or negative 3 to 13. So let's do 5 minus 1 over 13 minus negative 3. That's 4 over 16. That reduces to 1/4. Okay. This problem set's going to be slightly different. These are the kinds when point slope form is almost a preferred answer to slope intercept form. Now, choose an xy value. Do you want to choose the positives or smaller numbers? I'm going to go with the smaller numbers. So here's the thing. We have y minus 1 equals 1/4 times x plus 3. Here's the issue. They want slope intercept form. It's not a massive issue. The issue is just it's a fraction thing. What's 1/4 of 3? Not an integer. It's 3/4. 1/4 x plus 3/4. And I have to add 1 to both sides. That means I have to do 3/4 plus 1 right there. Not the most fun thing in the world. Slope intercept form, in this case, is uglier. Y equals 1/4 x plus, now 1 is also 4/4. So 3/4 plus 4/4 is 7/4. I mean, look, there's the answer. I'm done. But when it comes to trying to see this on a graph, you'd want to know what 7/4 looks like as 1 3/4, 1.75, and just be able to assure yourself that that's the number. When it comes to point slope form, I would have been done right here. Nothing looked like a fraction that I cared about. 1/4 is a slope. That's cool. I don't mind that. This one needed, for plotting points on a graph is weird, and we had to get a common denominator, especially if you chose these numbers here, 13/4 and subtract the 5 over or whatever. Man, that's a lot of other stuff. So you can see this is one of the examples where point slope form just was better. Point slope form was a better version of the answer for sure. So I'm glad they're throwing them in there, right? Let's practice some fractions. They're going to happen. So f of negative 9 equals 10. And f of negative 1 equals negative 2. Okay, let's start with writing what the points are. Here's an xy. Here's an xy. Let's go. Negative 2 minus 10 over negative 1 minus negative 9. That's negative 12 over negative 1 plus 9, or 9 minus 1, which is 8. And this is negative 3 halves. So slope of negative 3 halves, and yes, we're going to write the final answers with fractions here. Hope that's okay. So let's go for the bigger numbers this time. Let's make it harder. Y minus 10, listen, or how about this? I'll choose these numbers. You try these numbers, do the same distribution stuff, see if we get to the same answer, because we should, right? The answer should be the same. Y minus 10 equals negative 3 halves times x plus 9, and I got to distribute into here. So if you chose this set of points, distribute negative 3 halves into your two terms, and then see what you get. Now, I get negative 3 halves x minus 27 halves. Ew. And even more so ew is I got to add 10 to both sides, and 10 is also 20 over 2 as a common denominator, multiplying top and bottom by 2 over 2. But then that gets me to combine to y equals negative 3 halves x. Negative 27 plus 20 is negative 7, so negative 7 halves like that. If you use the points negative 1 and negative 2 in point slope form, did your distribution, it actually might have been easier for numbers, common denominator wise, stuff like that. But you should still get negative 7 halves as I did. But once again, it's one of the ugly fraction things. I mean, that's negative 3.5. It's not the worst fraction. But it's a fraction. Fractions are ugly for points. Slopes, fractions are great. Points. Okay. In number 27 to 30, tell whether the data in the table can be modeled by a linear equation. Explain. If possible, write a linear equation that represents y as a function of x. Okay. We still get to go pretty shorthand for these ones. They're not much more than what we were doing before. If they're not linear equations, we can just say they're not linear and move on. Those are the most fun. But I'm sure they're going to start us off with something that's linear. Actually, I'm not so sure. So the very first one, x's are increasing. I mean, look, this is something we did in chapter 3, but x's are increasing by 2s, a constant amount. Our y is increasing by a constant amount, plus 6, plus 10, plus 14, plus 18. Once we saw plus 6 and plus 10, we could have said no. So this is not linear, so we cannot write a linear function based off of this. This cannot be modeled by a linear equation because x's and because y's are not increasing by a constant amount. Next time they say explain, I probably won't explain. I'll just show you the numbers that I got. We're not going to write a linear equation here because it's not constant, right? Okay. Number 28. I have to copy and paste it, so give me a second. Let's see if they can give us one that we can write an equation for this time, so we can practice. Okay, number 28. X's are increasing by 2s. Now, these numbers will help me for something else I'm going to do in a second. But x is increased by 2s, y is decreased by 6s, it looks like. So this is linear. I'm just going to write linear. Here's your reason. Here's the other cool part. I got to start what I'm going to do next. They said write a function. We're going to use point-slope form because here's the thing. They never found an x value of 0 to get the y-intercept. Therefore, point-slope form seems to work best. Now, I would say choose any points to build the slope, but guess what? You chose a bunch of points to already get your slope. Slope is not just y2 minus y1 or x2 minus x1. It is that, but it's your change in y over change in x, and we're seeing it right now. Your slope is negative 6 over 2. Negative 6 over 2. It's literally that. So negative 3. We have it. What you get to do after that is choose an xy value. You have your choice. You have 5 to choose from. I can choose any of the 5. I can choose all 5 and rewrite it in slope-intercept form. I'll get the exact same answer. These are all solutions to the same equation. I'm going to choose the ones that are small and positive. So here I got y minus y1 equals m times x minus x1. And the cool thing is you can choose any of the other ones and you'll get the same answer once you distribute and then add 4 to both sides. Or add whatever number you have. So I have y equals negative 3x plus 7 as my final result for that one, number 28. What was I going to say? I don't remember. Oh, I didn't use f of x because this has a y that's there, so that's the variable that we can kind of base it off of. All right, number 29. Just because the table's vertical doesn't mean we can't do the same thing. Now, just because these are decimals doesn't mean we can't do the same thing, as long as we have a constant change. So number 29, we have... Okay, the x's are a little tricky here, so I want you to see if you can follow along with what's going on, and we'll see if the y's do the same thing. So x's are not increasing by a constant amount this time. This is plus 1 and plus 1, sure, but now this is plus 2. Let's see if this kind of follows that thing. We're adding 0.2, 0.2. You know what 1.6 plus what gives us to? 0.4. Okay. In terms of proportionality, and I don't know how big you're on proportions, plus 1 plus 1 plus 2. 2 is twice as much as the ones that we're adding here. Plus 0.2 plus 0.2 plus 0.4. 0.4 is twice as much as the 0.2s we're adding here. It looks linear. They're increasing by the same jumps as x, if that makes sense. It's the same form of increase. So this is linear, as if to state that the missing value here, 3 and 1.8, should also exist. You know what I mean? So that would also be there. Now, when it comes to slope, our slope is change in y over change in x. I could write that. 0.2 over 1 is 0.2. That's up to you. 0.2 or 1 over 5. I'm going to write 1/5 because that's how I roll, right? I tend to go more in fractions for actual numbers, even though they had decimal. I don't know. When they have decimals, I'm thinking about it. I might just use the 0.2. I might use the 0.2, but 0.2 is also 1 over 5. Anyway, there's our slope, at least it's exact. Now, they said write an equation. We've been dealing with point slope form the whole time. I get it. But you know what? this is one of the first times they actually gave you the y-intercept. X is 0 here. That is your y-intercept. So I'll tell you what. We know what our final answer is going to be, but I'm still going to use point slope form to get there. Your y-intercept should be 1.2. We can see it clear as day, so we can double check this. I'm going to choose two values that are just so good to look at right here, and we're going to plug them in. So we're going to have y minus y1 equals m times x minus x1. Or y minus 2 equals 0.2x minus, that's 0.8. So as I add 2 to both sides, I'm just hoping that negative 0.8 plus 2 is 1.2. It is. 2 minus 0.8 is indeed that, so that should be the answer. So just goes to show that your y-intercept did indeed show up as a result of something there. It's good. This was linear, despite its look. So a little tricky of a problem, which makes me kind of worry and fear over what 30 is going to provide. So number 30, you don't have to worry too much about 30. Number 30 is doing what? You might look at those y values and say, you know what? Yeah, those y's, they're subtracting by 3. Oh man, all's good in the world. We're looking so great, y'all. We got a linear function. Look at this. Oh yeah, got minus 3s. Here we go. And we're all good. But guess what? The x's are not changing by a constant amount. That's plus 1, plus 2, plus 4. Now, we could make the argument that the x's aren't constantly changing as y's are. Technically, the y's then therefore aren't constantly changing as x's would have been. But nonlinear. X's are not changing by a constant amount as y's are. What does that mean? We're done. We don't have to write anything else on that. Got a lot of practice on those. Let's jump to error analysis on number 31. Describe and correct the error in writing a linear function g with the values g of 5 equals 4 and g of 3 equals 10. Let's first get a picture of what it is they have here. They did 10 minus 4 over 3 minus 5. So far is so good. This is a y value, that's a y value, and they went this minus this, and here's an x value, 3 minus 5. So far, so good. 10 minus 4 is 6, 3 minus 5 is negative 2, that's negative 3. Their slope is good. They started off strong. So far, so good. Check. I'm not going to rewrite that part. When they do this y minus y1 equals m times x minus x1, here's the thing. M doesn't just multiply with x. I think the issue is their formula. Their formula is wrong. They need parentheses around it. So their substitution, y minus 4 is good. Here's the minus 5 there, which is good, but this needs parentheses. They added 4 over to get negative 1, but you can't do that until you distribute the negative 3. So their issue is their formula for point slope form is incorrect. Their point slope formula is missing parentheses around the x minus x1 quantity. And it changes the final part of the answer. The slope is good. The substitution of the values are good. The formula is just wrong. So we should have y minus y1 equals m times the quantity x minus x1. Same numbers as they have, though. We can use that. Y minus 4 equals negative 3 times quantity x minus 5. And then we distribute and add 4 over like we have been. If we're writing in the form, and then we're going to use g of x for the set. So plus 15, and we add 4. I'm going to turn y into g of x instead of y equals. I'll say g of x equals, and we got negative 3x plus 19. Plus 19. Plus 19. Okay, that's number 31. 9 more questions? Number 32. Error analysis. Oh, so there are 2 error analyses. Describe and correct the error in writing an equation of the line that passes through the points 1, 2, and 4, 3. They first go for slope. Let's see how their slope's looking. 3 minus 2 over 4 minus 1. That's good. Y's and x's. That's 1/3. So far, so good. Slope is good. Y minus 2 equals 1/3 times x minus 4. Okay, an interesting version of what they do. In just that these aren't the kinds of errors that I generally see. There's an error. This just isn't a common student error that I see. They chose a y and an x for their x1, y1 point to substitute from different points. I don't know if that sounded right, but basically they substituted, notice they chose this y value of 2 and this x value of 4. They were from different ordered pairs. From different ordered pairs. They have to be from the same one. You can choose one or the other. It's okay. You can do both. They just, well, I mean, both separately. You can't do one from one from the other for a single equation. So if we chose the ones on the left, we could have y minus 2 equals 1/3 times x minus 1. Or you could do y minus the other one. 3 equals 1/3 times x minus 4. So this or that would get you to there. What are some things that I more so see that are different from what they did? Swapping these ones. This is written on the left. You know how many people are going to write this on the left instead of on the right? And this one's on the right? I'm going to see that a lot more. And you know, the other mistake I'm going to see is if this has a negative, then they won't write the negative there, right? A plus. They'll just keep it as a negative. So those are the things that I'll see that are more of mistakes. Okay, number 33. And I'm telling you guys because you might be bound to make that mistake. Don't say I didn't warn you. Number 33. You are designing a sticker to advertise your band. A company charges $225 for the first 1,000 stickers. Oh, I feel like X is supposed to be stickers. For 1,000 stickers, we choose $225 and $80 for each additional 1,000 stickers. So that means another set of 1,000, 2,000 would give you. Oh, you know what? I guess we don't need that. Hold on. If that's the slope, that's M is $80 per 1,000 stickers. How about like that? Now, 80 over 1,000 is 0.08. And I'm going to write a decimal. We can do a fraction or decimal. I'm going to write the decimal. Write an equation that represents the total cost of the stickers as a function of the number in thousands of stickers ordered. Okay, let me do that again. Our thousand number is in thousands. If 1 is the first 1,000 stickers, it's $225. So $80 per one set of 1,000 stickers is what we're going to have here. So instead, our equation will look like this. Let's not use y and x. Let's use a company charges $225. So our charging or cost, I'll say C, and S for stickers, sure. C sub S equals, and then, or not equals, hold on a second. You know what? I'm going to use y next to begin with. All right, we're going to do y minus y1 equals m times x minus x1. So this can be y minus 225 equals 80x minus 80. And if we add 225 over, now we'll get the cost, the amount that we charge is $80 per 1,000 sticker times the number of sets of 1,000 stickers, plus an additional, what's that, $145? $145 just for funsies. So this can be our equation. If I use some sort of function notation, I could do some sort of like C sub S equals 80 times S plus 145, something like that, where S is number of sets of 1,000 stickers, C is your overall cost. It says find the total cost of 9,000 stickers. So 9,000 stickers, I don't substitute 9,000, I substitute 9. 9 is in thousands. So there. So that's 80 times 9 plus 145, which is 720 plus 145, or $865. For 9,000 stickers, we're going to charge $865. So this was part A, and then we have here part B. All right, number 34. You pay a processing fee and a daily fee to rent a beach house. The table shows, let's copy paste that. The table shows the total cost of renting the beach house for different numbers of days. 2 days, 4 days, 6 days, 8 days. We're going to assume it's going to be linear. Oh, actually, they're asking if it's linear, but if it wasn't, then the problem would kind of be done. So is it linear? Explain. Okay, so we're looking for a constant rate of change on part A, and my explanation will be, check this out. We're adding 2's. Not my favorite addition coming up. Let's see what this is all about. Let's find an easy one first. This is 204. All these 204? Oh, yeah, totally. So 204, 204, and 204. So totally linear. See the rate of change that's constant. We're going with it, right? Part B, what is the processing fee and the daily fee? They said processing fee, so the processing fee is like that initial startup, how much they're going to charge to just process this thing. So that's the y-intercept. The daily fee is your slope. The daily fee is actually the part I can answer first. That is slope. We can see our rise over run up $204 over 2 days. That's $102 a day. $102 per day. This is the daily fee. That's your slope. Using that information, we can get the processing fee by using point slope form. Let's choose the smallest numbers, of course, in our formula as y minus y1 equals m times x minus x1. Oh, 204, not 240. 204. So this will be, if you add 246 to both sides, this other value, the y-intercept, will be the processing fee. So this will be y equals $102 per day times the number of days plus a processing fee of $42. So processing fee is that guy. Fee. That's a couple E's there. And here's our daily fee right there. So that's part B, and there's our formula for it. We can probably use it for part C. You can spend no more than $1,200 on the beach house rental. What is the maximum number of days you can rent the beach house? So this one here, we can kind of do an inequality. Think more chapter 2, but we have our equation. Y is the amount that we're going to spend. We can spend no more than $1,200. So $1,200 must be less than or equal to, wait a second, must be greater than or equal to what it is that we can spend as a whole based on our number of days. So here's how much we're comparing against. Here's how much we're spending based on X days. We're going to solve for X by subtracting 42 from both sides. 58 equal 102x. And then divide both sides by 102. Let's use the calculator for that one. So I'm getting 1158. Oh, my calculator's reset again. 1158 divided by 102. And I'm getting 11. Okay, I'll show you it. I'm getting 11.352, etc. So here's what I'm going to write. I'll just write 11.4. 11.4. Now, X is a number of days, and I probably want to turn this around like that. We have to be less than or equal to 11.4, which means we can't round up to 12. If we went 12 days, we spent too much. That's more than 1,200. So 11 days is the most that we can go and not be above 1,200. Okay, 11 days. 11 days. Okay, number 35 on writing. Describe 2 ways to graph the equation. Okay, we get to actually look at something. They said describe. I'm fine with describing, but my information that I pull out is my description-ish. And I am going to graph. So number 35 is y minus 1 equals 3/2 times x minus 4. Okay. 2 ways to graph. First way. I'll put A. First way is point slope form. And I'm going to start with point slope form to show you that slope intercept form is the same thing. Point slope form. Pull out the information. Pull out the information of the slope and point this crosses through. Start at that point and apply the slope from there. Okay, we haven't done this yet. We're going backwards of what we've been doing. So take a look. For point slope form, our slope is 3/2. What's our point? This is the thing we need to practice. What's our x1, y1? x1 is this guy. It's not -4, right? It's 4. This is not -1. It's 1. Now, what does this all mean? We don't start from a y-intercept. We start from the point 4,1, okay? We start from 4,1, and we apply the slope of up 3/2. So we can do this. Instead of a y-intercept, some random place, we can go 4,1, boom. and up 3 over 2, up 3 over 2, etc. And boom, we have our graph. Down 3, left 2, down 3, left 2, down 3, left 2. That's one way to do this problem. Draw this graph. This is how you can graph out a point-slope form. We are in point-slope form, therefore, voila, we can do it. Now, what's another way we can do it? We can graph out of slope-intercept form. Now, I'll tell you what I'm going to do for slope-intercept form, we've graphed slope-intercept form plenty of times. We had a whole chapter, not really a whole chapter devoted to it, but the last chapter had this as a feature. So I am going to give you the slope-intercept based off this graph. We can see our slope-intercept's -5, okay? Keep in mind, this is where we started for this point, for this problem, 4-1. Our slope-intercept, we reveal, is -5. Without knowing that information, because we wouldn't have the graph yet, another way to do this is through slope-intercept form, which means get your equation in slope-intercept form and graph as you know how to. Slope-intercept form. Get your equation in this form, then graph with slope and y-intercept. Just like we always would. So, how do we get that equation in slope-intercept form? We've been doing it the entire section. Y minus 1 equals 3/2 times x minus 4. Let's check it out. Y minus 1 equals 3/2. So this is a really good problem. This is one of my favorite problems on you after doing a lot of practice. This is the problem that goes back to, hey, I actually got to graph a problem in point-slope form. I don't even know if they really wanted us to. They said describe it, but I really wanted to get one done. All right, here we go. 3/2 times the -4. This is the burden that you bear when doing this. 4 divided by 2 is 2, times 3 is 6, so we get -6. Then we add 1 to both sides, and we get y equals 3/2 x minus 5. Hey, this has a y-intercept of -5, and our slope of 3/2 would have still applied to this, so it's still the same graph, guys. It crosses at 0, -5. It crosses at 4, 1, like we saw right here. This was that starting point for this. It's the same line. You can do either or. In all honesty, this one from here, for me, was easier, given that we were in the form already. I wish they said, which do you prefer? For that, I prefer point-slope form. I do. Number 36. The graph of a linear function passes through the point 12, -5, and has a slope of 2/5. Represent this function in 2 other ways. Okay. Do they mean equation-wise? See, I don't know what they mean. I don't know if they mean represent it in... I think they mean equations. So if they mean equation-wise, we have, again, a point of 12, -5, and a slope of 2/5. Or do they mean, like, come up with, like, equate, like, other information? Oh my gosh. Function. Okay. I'm going to do 2 different equations. So we've been doing this whole time. So we can do y minus y1, so y plus 5, equals m times x minus 12. So here's one way. One way. The second way is, of course, distributing the 2/5. Ooh, this is the less fun one. But we can distribute the... I can choose the other way I'd do it. We've been doing slope-intercept form this whole time. You know why I'm at pause of using slope-intercept form? Because doing this would mean a fraction and then all that stuff. You know what I prefer to do? Let's find another point on this graph, guys. This is point number 1. Let's find a point number 2. Mr. Robinson, how do you find a second point on this graph? We have the slope right here and this point. From this point here, let's rise 5 and run 2. What's 5 up from -5? 0. What's 2 over from 12? 14. Let's use that. Y minus y1, boom, equals m times x minus x1. How about that? There's another version. They're both in point-slope form. Point-slope form is magnifico. Some of the best stuff. We can use it totally like that. Rise 5, run 2. Rise 5, run 2. And there's a version. That's what I'm using. Number 37. Reasoning. You are writing an equation of the line that passes through 2 points that are not on the y-axis. Would you use slope-intercept form or point-slope form to write the equation? Explain. Well, it's a very leading question here, but you would use point-slope form. I would use point-slope form because slope-intercept form requires requires that I know the y-intercept to write out. If I want to get into slope-intercept form, however, I would start with point slope form to do it. Therefore, I would still prefer point slope form. Now, all this comes with a very massive caveat, guys, and it's not one that you probably want to hear, but there's another way to get in slope-intercept form not using point slope form whatsoever. It's actually just using slope-intercept form, and it's one that I wouldn't mind talking about at some point. The last section should have talked about it. Section 4.2, 4.1. If they were ready to talk about it. It seems like they weren't yet. I'll let the book reveal things when they're ready to. I think they want to show you point slope form so you're not hesitant to use it in the future, because there's benefit to it, and sometimes you kind of really want to use it. Like a question like this. You have 2 points, neither of them are on the y-axis. The idea of the y-axis is that would give you the y-intercept, and we don't have it in this case. So you really want to use point slope form in this kind of case like this. All right, number 38 says, how do you see it? The graph shows 2 points that lie on the graph of a linear function. And this point does not look like a friendly one. This one looks fine. This one, I can't tell what that y value is. Does the y-intercept of the graph of the linear function appear to be positive or negative? Okay, I'm going to cheat, but it appears to be negative. Let's see. Aha, I was right. It appears to be negative. If I draw a straight line, that's... Listen, you can use a ruler. You can draw your finger through it, so I guess it's not a total cheat. So part A, it appears to be negative. Because when I draw a line through the 2 points, the line intersects the y-axis underneath the x-axis, which are negative values. Underneath the origin. All right, part B. Estimate the coordinates of the 2 points. What 2 points? Oh, these 2 points. I thought they meant of the y-intercept. How can you use your estimates to confirm your answer in part A? Well, they asked how I can, not should I, but okay, let me kind of hide this one out of the way now. So my 2 points, my first point, or the more obvious point, looks to be 8, 4. And let's see, 4, 1.75. I can use point slope form to confirm. Well, let me type it. I can do what we've been doing. I can use point slope form to get into slope-intercept form and confirm the negative y value. Now, because I wrote this one as a decimal, I'm going to keep it in decimal form when I do this. I don't know if we're required to do it, but one more practice problem like this wouldn't hurt. So this slope is a rise over run of 2.25 over 4. If I multiply those by 4, I get 9 over 16. Oh, wait. Should we write... Hold on. Let's write that as a decimal, actually. 2.25 over 4 is 0.5625. Oh, that's not a very good decimal. 0.5625. You know what? I changed my approximation of my number. So 0.5625. So this will be, I'm going to choose these numbers here. Y minus y1 equals m. Oh my goodness. 5625 times x minus x1. So that's y minus 4 equals 0.5625 times x oh, whoops. I'm distributing. This is x minus, and 0.5625 times 8 is 4.5. So x minus 4.5. That's a little cleaner. So it didn't really matter what my slope is anymore now, right? I just got to add 4 to both sides. And guess what? It says y equals 0.5625x minus 0.5. So this negative seems to confirm, that's a check mark, confirm that we do have, or confirmed, a negative y-intercept. Does it look like it's around negative 0.5? I guess so. It's the way that I drew the line, and I probably didn't draw it best. Let's fix that a little bit and see what comes of it. Yeah, totally, yeah, look at that, around negative 0.5, okay. Okay, guys. Let's go to, yeah, negative 0.5. Number 39, 2 more questions. Connection to transformations. Oh, 40 is big. Connection to transformations. Compare the graph of y equals 2x to the graph of y minus 1 equals 2 times x plus 3. Make a conjecture about the graphs of y equals mx and y minus k equals m times x minus h. Okay, so 39. Y equals 2x is here. And then y minus 1 equals 2 times the quantity x plus 3. Let's distribute 2. Will they be the same? Will they be the same? Will they be the same? Will they be the... No. 2x plus 7. So how do they compare? This 2x is 2x plus 0. So their comparison to me is same slope, different y-intercept. But I can draw a bigger conclusion off that. These lines are parallel. Now, I believe the next section is about parallel and perpendicular lines. So you are forgiven if you don't officially know that parallel lines need to have the same slope in different y-intercept, but these lines are parallel. It says make a conjecture about the graphs of these two. My conjecture has to be based off my own personal knowledge and information. But my conjecture is these two equations will either always be parallel or the same line. The same line doesn't make them parallel. If I got y equals 2x and y equals 2x, they're not parallel. They're the same line. And it's possible they could have both gotten y equals 2x if I got an x1, y1 set that would have turned this into a 0. So it's possible. Some people make a conjecture say they'll always be parallel. That's a little off because they could be the same. Conjecture that they're the same is also incorrect as well. So they could be one or the other. And that's it. They'll either be one or the other. All right, last question is number 40. Is there a part C? There is. Let's see. Comparing functions. 3 siblings each receive money for a holiday and then spend it at a constant weekly rate. The graph describes siblings A's spending. Okay, so you see graph there. Sibling B's spending is the table, and sibling C is y equals this guy here. The variable y represents the amount of money left after X weeks. Okay. I'm going to copy those two visuals, and we're also going to write the other equation. So we have A. Is that large enough? I got A, B, and C is y equals negative 22.5x plus 90. Now C is in slope-intercept form. All right, they said which sibling received the most money and the least money. Now for us here, we're going to have to know what the y-intercepts are for each point. So they received, so for this part A, I'll put in green, they received $90. This y-intercept here is 80. They received $80. This one, we can't actually see the information. I don't know if we're supposed to get into that stage here of point slope form. I think I'm going to ignore it as long as I can. As this increases by 1, this decreases by $25, which means if we go 1 week up from here, we can add $25 plus 25 or plus 1, see, I guess minus 1, which means that's $125. So they received $125 to begin with. Person B received the most money. If we wanted to, let's see, in order, this is B got the most, A got the least. Poor person A. Now, regarding person B stuff, even if you didn't know what the amount was, note that A started with 80, C started with 90, and B still had 100 even after week 1. Even if you didn't get B's amount of 125, whether you went slope-intercept form and such, or whether you did what I did on rate, you still should know that B got the most. Part B, which sibling spends money at the fastest rate. B, okay, this is where I got to just write the information this time. A, we'll figure out in a second. B, we spend $25 per week. You just saw that up above. This is 25, down 25 every 1 week. C is $22.50 every week. C is $22.50 per week. A, is where we have to do this y2 minus y1 over x2 minus x1 stuff. Or we can kind of count in our head. We're going from 50 to 20, that's down 30. And we're going over 2. 30 over 2 is $15 a week. So person A is 15 a week. Which sibling spends money at the fastest rate? Person B. Fastest. Slowest is person A. So now they're going, A received the least, but they're spending the slowest. How wise. And then C's kind of been in the middle for both. Part C, which sibling runs out of money first? Which sibling runs out of money last? Let's track. This isn't, I'm not making this so much a point slope form problem, and I apologize for that. Let's see if we can visually represent that on A in a moment. B, we're going to run out of it at 5 weeks. Another 25 down is $0 at week 5. So person B is 5 weeks until they run out of money. 5 weeks. Person C, let's use the equation negative 22.5x plus 90. So n equals 0. Let's see when they, oh my gosh, what happened? Negative 22.5x plus 90. Let's solve for this one. I know it in my head, but I'm going to add 22.5x to both sides. I set this equal to 0 to find out how much money they have after x weeks in this case. So if I divide both sides by 22.5, I believe I'm getting 4. Person C runs out after 4 weeks. Now, Keeks, 4 weeks. Now, person A, if you look at their graph, they receive it after 5 weeks. They run out of money after 5 weeks here. I don't know how much exactly, but if B was at 5 and C was at 4, A being more than it, I don't know. We could figure it out, but that would be an x-intercept anyway. I'd have to do a lot more information to get an equation and then plug in 0 for y to solve that. So I'm going to leave it, but it's more than 5. I'm going to say it's around 5.25. 5.25 weeks. Which sibling runs out of money first and last? Person C runs out of money first. Person A runs out of it last. Even if it wasn't exactly that, we know where we can get that information. So that last one, guys, I chose not to do so much point slope form. I think it's okay. I hope it's okay that we made sense of it. In any of these equations, we could have done it, right? Gotten these one. This one, I'm not going to use point slope form there. It's already slope-intercept formula. But I could use point slope form by getting my slope here and y-intercept. I think at that point we probably should have. This one here, I don't know, visually we kind of have everything involved. So I think we're pretty good there. Guys, that ought to do it for this one. This is Mr. Robinson. Thank you so much for watching. Yes, I did start pretty philosophically heavy with this. I want to make sure we accept the formula for what it is. It's a new formula. It's different. You get so used to one, you learn to love it. We have to break our mold from it, especially when the book didn't have us graph out a point slope form to begin with. And that's something where I can understand. You're like, I'm writing in the form, but for what greater good? Obviously, because we can write in slope-intercept form. So especially when we don't have the graph, it's a good one there, and I hope we keep using it. I believe next we have something about parallel and perpendicular lines. Get ready for that stuff before we dive into any sort of quiz for the chapter. I hope so far so good for us with this one. That'll do it for now. Take care. I'm going to see you in the next one.